Alrighty, Mr. Allen, River Dog Jenny here for another episode of Math in the Wild. This time, Jenny, we got a project on our hands that has not yet been done like the other ones. We want to make our boat here more winter accessible. Okay, so we're going to work on an enclosure for the boat, and we got to do some math calculations to get the materials ordered. Because I'm just going to willy-nilly it, right, Jenny? We don't want to order too much. We want to make sure we order the right amount of materials for this thing. So let's hop to it. What do you think, Jenny? I'm thinking so. We got our pencil, right? I'm strapped with the TI-84 Plus calculator, and of course, boom, tape measure. All right, let's do this. Behind me, you see we've got our boat here, but it is currently covered. And Jenny, do you feel like uncovering it right now? No, I don't think either of us do. So we're gonna do some calculations. Jenny just wants to go play. We're gonna do some calculations while it's covered, so we can order the materials and then just uncover it when it's time to go. Alrighty, so let's take some measurements. All right, so we're gonna be using that bimini top. You can see it's covered right now. This is the bimini up here, and it would unfold, right, and basically provide our initial structure for this thing. So what I'm gonna do is I'm gonna take a height measurement from where these snaps are, because I plan to use these snaps as a part of this, up to the top, and I already did so, and it is about 5 feet. So that is one measurement that we need here. Excellent. I had to set the phone down for this next measurement here. I want from here, this is where I plan to have this cover stop. I'm going to attach it to a seat that's inside the boat that you'll see later. And then it's going to go all the way to the back of the boat. I measured that in pieces because it was a little hard to reach the tape. To here was about 7 feet, and to the back is about another 7 feet. What's 7 plus 7? That is 14 feet. That's some quick math right there. All right, awesome. So we've got our height and we've got our length. That's gonna be quite helpful. Now the other measurement we need is what's the width of this boat here? Well, if I pop around back, boom. If I were to measure from here on over, this is an 8-foot wide boat. I believe they call that an 8-foot beam. So I've got 14 feet running this way. I've got 8 feet this way, 14 the other way, and 8 feet in front. Those are some solid dimensions, I'd say. Now, there's one other thing here that we're going to have to worry about, and I'm going to pop up a picture of this boat so you can get a picture of what's going on. All right. So we got a picture of the boat up here, and what I want you guys to do is pay attention to where that bimini stops as it goes towards the front of the boat, where that cover stops, and look straight down to the rails of the boat and see where is that. It's right in this area where these stickers are, Fox Waterway Agency stickers. And I can see actually where the rope hooks right here through the cover. It's kind of pushing out a little bit. So I'm going to use this as my reference spot. All right. And what I've got here is if I take a measurement from where it's going to end to where that little pop out is, it's right at 3 feet. Excellent. I like it. So, now what? So we said it's 3 feet to this, and it's about 5 feet to the top of the bimini. Jenny, I think we're gonna need to go to the drawing board and do a little math here. What do you think?
Hold up. Mr. Allen, that looks like you've got a right triangle, but you're missing a hypotenuse. I'm like pretty sure there's something in math that can help you with that. Let me think. Students typically have a hard time saying its name. Totally fine, because the cool kids shorten it anyhow. So I think you should hit that with some Pythag theorem. And don't worry, if numbers get a little complicated, Mr. Allen, I know you're always strapped. Bust out that TI-84 and get after it.
Pythag it is, Jenny. Does that sound good? All right. Got a right triangle. We got our 3 feet. We got our 5 feet. And as Miss Folling said, thank you, by the way, Miss Folling, we want to get that hypotenuse there. Okay, so that'd be 3 squared plus 5 squared equals x squared. A squared plus b squared equals c squared. Pythag, you dig that, right, Jenny? You certainly do. Look at that tail wag. She loves Pythagorean theorem. Okay, so 3 squared is 9, and then 25 there for 5 squared equals x squared. So I've got 34 equals x squared. Now, how do I solve for x? If x is currently squared right now, I will take the square root on both sides. And that's not a perfect square. Darn, if it was 36, it would be. But it's not. So what I'm going to do is I'm going to plug it into my calculator right over here, TI-84. Yo-ro, 3 squared plus 5 squared equals 34, as we said, right? Just, decide to double check it. I got it right here. And I'm going to square root that, or I like to be fancy with it. I hit that little caret there, and then I go 0.5. Raising it to the 1/2 is the same as square rooting. Boom, hit enter, and 5.83 feet. Okay, 5.83 feet. That would be the length right there from here to here. Excellent. So I also want to make sure that I account for the vinyl coming down here, which is roughly a couple feet. So we'll add that to it. So we have 5.83 plus another couple feet. That's 7.83. So roughly, I would say in my calculations, just because I know that I'm going to have to cut some things off and fit it a little bit funky, I'm going to go with 8 feet for my 2 front panels a piece. So now I think what we need to do is start totaling everything up. The front panels, the side panels, and the back panels, and get a total amount of linear feet that we need to order, and then we'll convert that into yards. Jenny and I decided to move into the garage for this next part. We got 2 front panels at 8 foot apiece, and I've got 2 rear panels at 6 feet each, and I was able to actually measure that one because how the bimini is stored away. I was able to take the tape to the back of the boat. And then I need my side panels. So let's think about that for a sec. It's important to note that the side panels are, or the panels are all 54 inches in width, and then you order them in the linear yard, but all of the vinyl will be 54 inches wide. Okay, so that's one thing. The next part is the length of the enclosure. Now, earlier I measured and I estimated around like 14 feet. I went and double checked that because I like to measure twice, cut once, or order once in this case. And I was actually more by like 6.5 feet and 6.5 feet to that midpoint, which would then give me 13 feet to enclose. But those are 2 different units. So how about I convert the feet into inches by multiplying this by 12. And why don't we do that over here on the TI-84, so I got all my numbers stored. All right, 156. Boom. So that's the length of the boat. So how many 54-inch panels will I need for this? And you might actually be able to see this here in your head if you're savvy with numbers, but I'll go ahead and take that and divide it by the 54, and I get 2.8 repeating. So I need, if I divide this by 54 inches, I end up with 2.8 repeating. So about 3 panels. And I know I got that yo-ro right over here. You're like, Mr. Allen, why are you rounding along the way sometimes? Well, I know this means I will need 3 side panels, okay, on each side, and I am going to have these panels overlap just a little bit. That keeps the wind out. So I'm going to round that up at this point in time because I know I need 3 side panels on each, which makes 6 and that was the measurement of 5 feet, what I'll need to make those happen as the vertical measurement. Okay, so I've got 2 times 8 is 16. Jenny, is still with me? No, I don't think so. All right, so it's 16 feet. And then I've got 6 of them at 5 feet. That's going to be 30 feet. And then I've got 2 of them at 6 feet. That's going to be 12 feet. And if I add those all up, let's see here. 16 and 30 is 46. 56, 58 feet. Okay. So that's how much vinyl I need. But this vinyl is ordered in the linear yard. Jenny, how many feet are in a yard? She said 3. Very good. So if I take 58, and I'm going to come down here for this conversion, 58 divided by 3, that's going to give me my linear yards. So let's take 58 feet divided by 3. That means I'm going to need to order 19.3 repeating yards. Now, I'm not going to order a 0.3 repeating yard. They aren't going to give me a third of a yard. And I also want to make sure I have a little bit extra just in case. So what I'm going to do is I'm going to bump that up a bit. I'm going to decide to order 22 yards. That's what I'm going to order for this pontoon enclosure. 22 linear yards. That gives me, really like 1 extra, mess up in case I make a mistake on one of these. I got a spare. Ooh, that was a voice crack. I'm keeping it. All right. So how much is that going to cost me? Well, it's $11.70 a yard. So if I multiply the 22 yards that I'm going to purchase by $11.70, that gives me $257.4. So we're running out of room. $257.40. That's what it's going to cost me pre-tax and shipping. But at least I'm starting to get a rough estimate of what this thing's going to cost. And I can compare that to the actual cost of this thing, which I got quotes of like $3,000, $3,500. That's crazy, Jenny. We don't have that kind of money, but we do want to go boating in the winter, and that ain't funny. All right, so the next thing we got to worry about are these snaps, Jenny. How are we going to snap this thing down, right? Okay, so we got to get some spacing, I think, on the snaps, and then we get... She just wants to go chase squirrels. So we got to get some spacing on those snaps that you see there behind me. Let's take some measurements and see what the spacing is, and we'll just mimic that on the rest of it. So as I'm looking at these snaps, I've got this one here is 11 inches. Spacing here is about 12. Spacing here is 10. Plus I got an extra one, you know, as they're wrapping around certain things. So I got 10, 11, and 12. I'm going to go with, say, 11 inches. So we got an average of about 11-inch spacing, Jenny. 10, 11, and 12. We're going to go with 11. And we got a perimeter here of the boat. We've got the height. We're going to figure out how many panels we need, too. But this seems like, I don't know what kind of math we could use. Maybe we can call somebody for help.
Yo, Mr. Allen, I think you could set up a proportion to figure that out.
Thanks, Doc. Much appreciated on the help there. We're going to do some proportions. Whoop, whoop.
Hey, man, no problem. Glad I could help out.
All right, we're back in the garage here with River Dog Jenny, right, Jenny? Yep. All right, here's our pontoon enclosure. Remember, we adjusted the 14 feet to 13 feet. So this is like the outline of it, right, the perimeter of it. And we said we wanted snaps every 11 inches, right? That was like our average there. And as the doc said, we need to set up a proportion. So if we have, let's see here, one snap every 11 inches, how many snaps are we going to need every, wait, how many inches? We got all this in feet. My goodness, I think we need to do some conversions here. So, well, I know that 12 inches in every foot, so 8 times 12, that's going to be 96 inches. And we did this one, I think it was 156. I can't remember. We did that earlier, though. 13 times 12, 156. There it is. There we go. So if I've got 96 and 156, so I'll just add that to 96, and then I'll multiply that by 2, since there's 2 of each side. We got 504 inches. 504 inches. Woo! All right, I like that. So let's find, this will be the amount of snaps for the perimeter of our boat to go all the way around it. Now, by cross, multiply, and solve, I'm going to have 504. Jenny just can't relax. She's pacing the floor. She's so excited about the math. Equals 11x. If I divide 504 by 11, 46 snaps there. So 46, snaps to go around the boat. But that's not all of our snaps. The other part would be for the bimini top. Bimini. That's so fun to say. So again, this is going to be 96 inches when we convert. This will be 120 inches. And if we're going to do the same snap pattern with this one, why don't we find the total perimeter of that? 120 times 2 plus 96 times 2. I did a little bit different just because it's fun. And again, we have the one snap every 11 inches. So what are we going to have for our number of snaps after 432 inches? So if I cross multiply and solve once again, I'm going to have 432 is equal to 11x. So if I divide this by 11, still in the TI-84, we're good to go. We got 39.27. I'm going to, again, round this up a little bit because we can't get 0.27 of a snap. So we're going to call that 40 snaps. Awesome. All right, so we have 46 snaps around the frame and 40 around the bimini, right, Jenny? That's right. But then we also have the between the panels. Now, I'm not going to go with the same every 11 inches. We have a snap on this one because snapping those together will be kind of challenging from the inside of the boat. If we have too many, you can't reach your arm through. So what I'm just going to do is 2 to connect each panel is what my estimate's going to be on that one. And if we have 10 total panels, 3 on each side, that's 6. 2 in the front, 2 in the back, that's 10 panels. And if I do 2 on each one, that's going to be 20 snaps. So when I add that all together, I get 106. Bingo, bango. I like it. Now we'll see what the ordering comes in of of snap quantities and things like that, I'm sure I'll have to go more than 106, plus, you know, some snaps might snap off over time, so I'll have some spares, but that gives me a good idea of what to order on the snaps. Now, one thing I just thought of is that these snaps, I'm going to be drilling into the existing metal structure and then snapping the fabric, the vinyl, to that. So there's 86 of that style. In these 20 snaps, this is fabric on fabric, meaning, or the vinyl on vinyl. So it's actually a different type of snap. So I'm actually going to order these separately. So I'm going to have to see what I can find online. But once again, I mean, we got what we need here. It's time to go. It's time to order everything and get to work. All right, Jenny. So we ordered the materials. They've been shipped. They're here. I think we're ready to start this thing. You want to uncover the boat? Want to give me a paw? All right, let's get started. So part of working on this boat here over the open water is we're going to need a working platform for the back of the boat. So we built a temporary thing. We use this for doing like oil changes and stuff too, but now it can be for building the enclosure. What do you think about that, Jenny? All right, so my initial design plan of just having the front windshield snap into the bimini and just come down to the seats really wasn't quite strong enough. The snaps were just pulling off because of the weird angle, so I've decided to create this PVC structure to act as our windshield, and it will also likely look like a hockey net. So let's see how we're going to figure that out. So we got the start of it here, right, Jenny? She's not helping. We got the base going here. There we are. But what I do want to figure out is the angle that I need the windshield to come up so that it can connect right up to here. Now, initially, I actually thought it was going to be a 45, and then I thought again, wait a sec. If I go at a 45-degree angle, that's an isosceles right triangle, meaning it's only going to go as far this way and go up that amount. It's time for the drawing board. Got the calculator. Yo, row. Bub and bug. Stay hydrated. So here's what I'm talking about. Currently, that structure is about 20 inches tall, and that opening for the door is about 20 inches wide. Meaning, and that's where the next support will go, just beneath the bimini, which is 76 inches tall. Well, if I'm going up at a 45, I'm only going to be able to go up vertically as much as I'm going horizontally, because this is a 45, 45, 90 triangle. And we know that that's isosceles right, meaning this leg right here is the same length as this leg. So that would make this 20, this 20. So right from here to here, those two, it's only be 40 inches. And we need to go closer to 76. Now, it doesn't have to be all the way to 76, but I'd like to get kind of close. So I need to rethink what angle I'm using. All right, so I want to get as close to that 76 as possible here overall. So this is the angle that I want to find. Now, I do know, since I'm going to be using PVC, fittings come in 45s, they come in 22.5s. So if I had a 22.5 degree angle going up like that, this would actually end up being 67.5. And I want to find out what's this length going to be then if this was 67.5. So if I've got this angle and I want that side opposite it, and I know this one, which is adjacent to it, what could I use? Ooh, how about some trig? So that would be tangent of 67.5 is equal to the opposite over the adjacent, TOA, x over 20. And then I'm going to have to type that into my TI 84 plus calculator because I can't do that math in my head. But first I got to do a little algebra. Let's multiply by 20 on each side. And now I can just type in 20 times the tangent of 67.5, which I've got right there. It's a little hard to see. Let's hit enter and see what we've got here. We've got ourselves 48.28. So that means that's what x is equal to. Inches. So if I were to add that 48.28 inches to the existing roughly 20 inches, that would give me 68.28, or roughly 68.25 inches, which is a lot closer to 76. And this bimini up here actually ends a little bit before where the structure is going to be, so I'll have a little bit more room to just finish that length there with the vinyl, which is making the enclosure. Okay, so I think I'm going to go with that, because that 22.5 degrees and 67.5 degrees is a pretty nice angle to work with. They have fittings for that for PVC. Since I'm using PVC, I can work with that angle. If I really wanted to, I could calculate exactly what angle I wanted using inverse trig and then bend the pipe accordingly, but I'm just going to go with this this friendly PVC angle here. All right, so right behind me here, we've got our starting of the structure. Now, this is actually a 45-degree angle, and as we talked about, we're going to be using 22.5 and 67.5. Well, they don't make a 67.5-degree angle that I found anyways. So I picked up some 45s, and actually, I didn't do my math prior to going out and getting these things. I was just running it through in my head, and I was like, I'll just go all 45s, and then realized I'm not going to be able to go high enough with that. I have to go with 22.5s. So it pays to do the math beforehand, okay, like we were just doing. But instead of running back out, I decided I'm just going to go ahead and bend the PVC because I have a heat gun that will allow me to bend it to that 22.5, and I'll use some of these 45s right here on each end to get it to go down at that eventual 67.5-degree angle and go up at that 22.5. So I'll show you guys what I mean. So it makes sense to have all of our angles be as close to 22.5 as possible. So what I did is I took this scrap piece of 2x12 and cut a 22.5-degree angle on it. Now, how the heck did I get that? Well, I'll show you guys over here because I already cut this off, so I can't really show you. So if I take my speed square and see where it says pivot right there, pop that guy on the piece of wood wherever I want to start. So I went roughly a little bit beyond middle. And then what I do is I eventually rotate this out till I get to, I'm gonna go with 67.5 right there, scribe my line, and that will end up giving me that 22.5-degree cutout. This little angle right here will be 22.5. So there we go, and as you can see, I scribed the line. There's my 22.5-degree angle. This is my 67.5. How do I know that? Well, this is a right triangle. These two angles are going to be complementary. They're going to add to 90. So the two angles we're using here are 22.5, 67.5. Went ahead and I cut this one off. And I'm going to show you guys how I use that to then line up the PVC and bend the same each time. One thing I wanted to add here before moving on to bending the PVC is, why did I use an angle of 67.5 to get my 22.5? Well, when I pivot here, and I go to that 67.5, I'm pivoting off of this line right here. So I went ahead and scribed that line. And what we see here is this angle, that's my 67.5, which leaves me with this 22.5 right here, because again, this is going to be a right angle. 90 minus 67.5 is 22.5. So we often use one or the other to get each angle, depending on, the orientation and things like that. Now, let's go on to bending that pipe. A little hard to heat PVC and bend while holding a camera, so went ahead and did it anyways. But what we've got here is a nice little 22.5-degree angle, so that way I've got my two angles that I'm working with, the 67.5 and the 22.5 for that windshield. I'm gonna show you guys how that's all put together, but each one of these is going to be the exact same or incredibly close to it. So here we are. We've got our 45 into a 22.5, which gives us 67.5 when we add them together. And then it rolls on down to there. Lovely. So as you can see, I actually have a lot of different letters on here, and they have their like K prime, K double prime, K triple prime. My goodness. This is so I know how to put it back together after I take it all apart, because everything looks pretty similar. But as I'm going around and I'm putting these snaps in place for the vinyl to snap to, I'm not necessarily doing it exactly the same on both sides. I'm seeing how everything fits because not everything's always perfectly symmetrical. So I'm just going for it and then snapping in place where all the vinyl lays nicely. So I want to make sure everything goes back together the same, so that when I put it back together, it goes back the right way. Meanwhile, I'm working on this thing, and Jenny's just hanging out on the beach. How are we doing over there, Jenny? I think she found a pretty good stick. All right, let's keep going. So here we have it, the fully put together front windshield as promised. It looks kind of like a hockey net, which is kind of goofy looking, but hey, I think it'll do the trick. So now let's start assembling some vinyl. There are some cuts that have to be made and snaps put in place and all sorts of cool stuff. But let's get putting it together so this thing can be nice and toasty for a little river cruise. Hey, Jenny, how's it going? You coming to help now, or are you just gonna hang out there in the sun, the little bit of sun we have left? No, not gonna help? Guess we're on our own. So there's a front look at this thing before we get the vinyl going on. Now I already have the vinyl done. It's ready to rock and roll. Snaps are all put into place. So I'm just gonna show you guys a couple things of how we're putting it together. But it's all rolled up right here, 2 rolls. Now, the way that it goes on is opposite the way we take it off. We're going to start from the back and work forward on this, because then the vinyl will basically like flash over one another, so it doesn't let wind in as we go. I'll show you guys what I mean by like flashing over one another here in just a sec. Like I said, labeling is a smart move here. We got starboard, front, top. Starboard is the steerer's side, which would be where I'm going to be sitting right there. So it's that side of the boat, and then port is the other side. So we have them all rolled up in the two sides, labeled accordingly. Look at that. Port, boat terms. There we go. You're learning more than just math. We're learning boat terms. So there we are. We got one panel in place. Don't mind the ugly back seat there. I never really got to it. Maybe one of these days we'll reupholster it. We got to get a sewing machine, learn how to do that. But there we go. We got all of our snaps in place. A little hard to see with the glare. And then comes on down to the back. So we'll keep on moving here. So here we are inside the wonderful pontoon enclosure here. We got 10 total panels that have just been put up, 3 on each side, 2 in the front, 2 in the back, and it gives you a nice 360-degree view of the river because it's all clear vinyl. And that 360-degree view is wonderful when you're navigating the river because I don't want to bump into anything, right? That makes sense. So I'm going to hop on the outside of the boat here and show you guys what I meant about the flashing and how these things are put up. So that way when we are underway on the boat, I'm not taking in a bunch of cold air, and it's also not making one of those panels fly off because it catches the wind all weird. So let's take a look at that. Here we are on the outside of the boat, and this is what I meant by the flashing. The wind is coming across in this direction when you are underway, so I chose to flash it this way, or if you want to think about it as more of like a layering, where this panel here is on top of this one, and then this panel here is on top of the next one. So that allows the wind to go right past us, right over the enclosure, rather than going in the enclosure, keeping us nice and toasty on the inside, keeping that cold on the outside, and we can cruise this river here pretty much all winter long when the river is not frozen, obviously, which it doesn't freeze quite as often as like a lake would because this water is always moving. So who knows? We might be boating in January and February. So back to the math real quick. Remember we came with the 68 and roughly a 1/4 inch for the height of the PVC structure there. But 76 was the height to that bimini top. Well, look at that. We got ourselves about that 8-inch gap right there. Exactly as planned. It worked out. The vinyl was able to make the jump from there to there, and the PVC helped hold those snaps in place. I think we're all set. I think we're ready for a cruise. So Jenny, after taking the boat out a couple times in the enclosure there, nice and toasty, right? I think we've really increased our boating season. We usually would go, let's see here, a bit of April if the weather's nice, through maybe October. That's 7 months right there out of the year. But now I think, am I boring you? I think we could probably get all year round if the river's not frozen. So I wonder what kind of increase that is. You just want to go hang out. Okay, so we got to think, what is our percent increase of boating time on the water now that we have this enclosure? That sounds like another math problem. Then I think we're probably pretty good for this one. So to figure out my percentage increase of boating time in this wonderful enclosure, look at that, they're wearing jackets, not us in here. I'm gonna have to do the new amount of boating time, which would be 12 months, right? Subtract the original amount of boating time, which we said was 7 months, and then divide that by the original amount of boating time, which is 7 months. So essentially I'm doing 5 divided by 7. And there we have it. 0.714. Now, that would be a decimal, but I could write that as a percentage by multiplying by 100 or just moving the decimal place twice. But hey, why not? Why not multiply? We got the T84 right here. 71.43 percent increase of boating time. Now that's good stuff right there, right? If we can get all 12 months in, and I'm planning on boating every single month if the river allows, there we go, 71.43% increase. All right, it is January 17th. We're planning to take the boat up, but it is covered in snow because it snowed last night and this morning. So I've got my leaf blower here, 12-amp battery. We're going to see if that does the trick, because boats don't have defrosters, but we do want to take it out for a little January cruise. The boat has been uncovered. Now it's time to assemble the structure and get the enclosure ready. And then it's time for some boating. All right, so that's it for this episode of Math in the Wild with Mr. Allen and the one and only River Dog Jenny. Hope you guys enjoyed it. There's quite a bit of math involved in this one there to make that awesome enclosure. It's a little goofy looking, but hey, kept us nice and warm, increased our boating season, and that's all good things, right? All righty, you guys have a wonderful day. America, freedom, rock and roll, Costco, and River Dog Jenny. See ya.